The compmeansC function is one of the most powerful functions in the RCPA3 package, and we use it a lot in the book. The required arguments are fairly simple, but there are a lot of optional arguments and plot-related arguments which allow you to do a lot with compmeansC. In this video, I'm going to focus on the compmeansC function's plot-related arguments. I cover other uses of compmeansC, like making basic comparisons, controlled comparisons, and hypothesis tests in separate videos. The compmeansC function has two required arguments. dv is set equal to the dependent variable and iv is set equal to the independent variable. The compmeansC function supports a standard set of optional arguments. To generate a plot for your mean comparison, you set the function's plot argument to true, or you can set plot to line, bar, which is the default, or points. The function's main, xlab, and ylab arguments allow you to customize the plot's main x-axis and y-axis labels. You can use the plot.ci option to add 95% confidence intervals to the plot. The function's z.palette and legend.title arguments are used to visualize controlled comparisons, so I will show how they work in a video on controlled mean comparisons with compmeansC. To learn how to use the compmeansC function to create plots, let's work through some examples. Let's start by looking at some of the basic arguments you can use to create plots with the compmeansC function. Before the video started, I installed the RCPA3's package and loaded it with the library command, and also used the help function to call up the compmeansC documentation, which you can see in the help pane here. In a separate video, I showed you how to use the required arguments dv and iv to create a mean comparison table to show mean values of an interval level dependent variable by categories of an independent variable. And in the line I've typed in line 6, the compmeansC command you see here, that's basically what I'm doing. I've set the dependent variable to interval level variable in the NAS data set, feeling thermometer towards journalists, and the independent variable is party ID 7, party identification in 7 categories, and I added W equals NES $weights to weight observations to get more nationally representative results. I'm going to just start by running the command I already typed to create a basic mean comparison table, and this should create a plot excuse me, by default. Hit return to see that. Okay, so what are we looking at? We see the mean comparison table plotting. It displays the mean feeling thermometer towards journalists by the 7 categories of party identification. Means go down this column here, labeled means. That makes sense. And then over here in our plot window, we see a bar chart where the height of the bar is equal to the mean for each category. So the strong Democrats start at 72, and we can see sort of a general declining pattern as we move from left to right on the party ID scale, with it ending up feeling thermometer score of 27 for strong Republicans. So this bar chart that we see is the basic version of the plot, using like the default values for the main, xlab, ylab, and the labels of the independent variable values. Some of the basics you can do, I might have shown this in the basic use of the compmeansC video, but one option, there's a plot argument, and you can set plot to false if you don't want a plot and you just want to create the table. But you can also set, let me show you this in the help file, the plot argument. So do you want to plot? You can set it true or false. If you set it true, it will create a bar chart. That's the default. If you set it false, it will suppress the plot. The other options are line and points. You can type in bar as well, but that's the same as saying true or not putting anything at all, because bar is the default. But let's look at line, and then we'll look at points. So I can come back to my command, and I can set plot equals in quotes line. Let's take a look. Okay, now it's got these square markers for the means in each group, and then is connecting the markers, the points, with line segments. So it's not fitting a line, but connecting the dots on the line, creating a a plot of means connected by line, and it's a pretty good pretty good representation. I think it maybe shows the trend left to right more clearly than the bar chart does. Doesn't necessarily make great use of the space available, but I think it's pretty informative and not terrible use of the space available. We can definitely see the trend very evident there. Your other option is points. I'm just going to replace points where I said line, so add plot equals in quotes points. Let's take a look. So it's basically the same plot as the line plot, except for no line segments connecting them. We just have markers at the means without a connection drawn between them. And that may make some sense if we think that these 7 categories of party identification are really separate categories and shouldn't be connected with lines. I know it's kind of an interesting question in this case, whether it's appropriate to connect these with lines. I do think that they are ordered, and you can imagine gradients between them where lines would make sense and help to see the pattern. But on the other hand, it is 7 separate categories or 7 tiers of party identification. So there wouldn't be anything really wrong with doing the points. But again, that kind of criticism where you're making terrific use of the white space here and not filling very much in or not making something interesting to look at is true. But there are some options that maybe would address that, and also some options that I'll show you that would just generally make for a more concise and elegant and informative plot. But those are the basics. You've got the bar chart, the line chart, and the points. So I left off with this simple plot of points showing the mean, the observed mean in the NES sample, the feeling thermometer toward journalists by 7 categories of party identification, and it shows the points. And one criticism I made just from an artistic standpoint is it doesn't make quite much use of the white space. There's a lot of blank space in here, and it's not the most visually interesting plot, and for that reason it's not as informative as it could be. An option you have to convey more information without cluttering the plots, but actually I think making it more interesting, is the plot.ci argument. And by default it's false. It doesn't plot the confidence intervals, but you can change plot.ci to equal true to add confidence intervals for those sample means. Let me run it and see what it looks like. It's the same plot as before, but it has added confidence intervals for these mean estimates. The estimates are pretty tight, so it's kind of difficult to see the confidence intervals. The confidence bands aren't very wide. The margin of error is pretty limited here, particularly at this y-axis scale. But if you look close, you can see a line segment going through the markers, a little bit below it and a little bit above it. If you're in chapter 4 of the book, the confidence interval concept may not make much sense yet. We're going to explain it more in chapter 8 of the book, but just to preview it a little bit, it's an indication of the margin of error of the estimate, saying given that we are using a random sample to estimate the feeling thermometer towards journalists in the population from a small sample of NES respondents, that it would be plausible to think that the actual value of the parameter in the population of whole United States adults, which the NES is meant to represent, could be a little bit higher or lower, and the bars, the confidence interval bars that we see represent that uncertainty. And I think They're not dramatic in this case because it actually is a pretty large sample, and these are pretty tight estimates. But it adds a little bit of visual interest to the plot and conveys some additional information. So I think it's a useful option if you are working with a line chart or a points chart. I think the confidence intervals will work with a line too. So I'm going to just switch plot back to line and run it. Take a look at this version. Yeah, so this is kind of combining the two. We've both got a line connecting the dots together, as well as those small, in this case, relatively small confidence bars going above and below the marker. So it's maybe more informative, definitely better use of white space, and a kind of an interesting plot here. And we've got the bar option. I am fairly sure when we go back to bar that we don't add the excuse me, confidence intervals to a bar plot. No, we don't. I could be wrong about that, but I don't think so. So the bar plot doesn't add those confidence intervals. They would be kind of obscured here on the bar plot because it's already got sort of a lot of color on the plot, and it would be kind of, I think, random looking just to have a little marker at the top. So the bar plot option doesn't really use plot CI, so it's superfluous. We might take it out to avoid confusion. You have the standard arguments that you have in most plotting functions. Look at the help file. You can see we have the main argument, xlab argument, and ylab argument. Those do what you would expect from those arguments for a plot. The main label of the plot, x-axis label, and y-axis label. One that's helpful, and this would be helpful. I'm going to go back to the points plot for a minute with the plot CI with the confidence intervals plotted. To show you this. Now, one reason when you look at the points plot with the confidence intervals, it's a little bit hard to see those confidence interval bands is because of the scale that it's presented. It's going from 0 to 100. Those are the limits of the y-axis, goes fully from 0 to 100, but the action in the plot isn't all the way from 100 to 0. So you do have an option to use the y-limit argument to declare new upper and lower bounds for the y-axis. In the plot right now, it's 0 to 100. So right now it's 0 to 100. If I run this, I'll get the same plot. But if you want to kind of zoom in on the area that's actually used on the plot, you can do that by resetting the upper and lower bounds. So for example, in this case, I might want to reset the y-limit to 20 to 80. Let's run this and see what it looks like and if we're any more satisfied with the plot. Okay. You can see, I think it's quite an improvement, at least visually quite an improvement. If we look at our plot now using the y-lim argument from 20 to 80, so this x-axis, the area from 0 to 20 is cut off, and the area from 80 to 100 is cut off. It allows us to kind of focus in, zoom in, and see the confidence intervals more clearly than we did before. So that is a good thing. I think a downside of doing this, however, is the possibility of exaggerating, or I guess I would say like lying with statistics. Because you can imagine a situation where there is not really a dramatic difference between them. Say we had another situation, if the feeling thermometer means just went, let's say, from 50 to 45, we could, zoom in the area between 50 and 45 and make it look like it's very dramatic when in fact it's not. I mean, but at least the x-axis, the y-axis here is still going to indicate the scale. So in that way, it shouldn't be too deceptive because the scale is transparent to the reader. But the first impression, depending on how it's used, could be somewhat deceptive. So use some caution, I think, when using the y-lim. But in some cases, it can be very helpful and help draw attention to the area of the plot that you want to draw attention to. The last thing I want to demonstrate, I'm going to go back to a bar plot for this. Is the use of the IV labs argument. And the IV labs argument gives you a chance to change the default labeling of the independent variable values. So the variable values, there are 7 possible values, 1 through 7, like you can see on the table. And they're very descriptive here of the party ID categories, all 7, but you run into a bit of a problem. Not a dramatic problem with the table, but you start to see a problem with the figure where the labels get fairly long and are running into the space typically given to the x-axis label. Like you can even see here in the plot window that label 5, independent Republican, is kind of overlapping the default X label. And so you can use this IV Labs label to change the displayed values. And you would set the IV label equal to a vector with 7 items, and the 7 items would be the 1, 2, 3, 4, 5, 6, 7 items, 7 labels of the independent variable values. I'm going to fill this out. I'm going to pause the video to fill this out so you don't really need to see me typing, but I want to show you what I do and the effect of it. So my vector of new independent variable label values has 7 parts: strong Democrat, moderate Democrat, lean Democrat, independent, that's that number 4 middle category, then lean Republican, moderate Republican, and strong Republican. I think these are faithful to the original labels, but more compact than they were before. And when you do this, you want to be careful to make sure that you're inside this vector, in the concatenate function, that all your values are enclosed in quotes and separated by commas. And kind of a nice feature to error check in RStudio is if I click after the last parentheses, it highlights the opening parentheses that parentheses corresponds to. And if I do the same with the second to last parentheses, you see how it highlights the parenthesis at the start of the vector. So I've got parentheses paired right. I think this will work. Let's give it a run and find out. Table looks good. Okay, so what do we think here? The table looks more elegant, more compact, takes up less space, but I really like what it does with the plot here. We've got more concise labels, but the labels are equally, if not more informative than they were before. So that's a real upgrade when you can convey the information more concisely, taking up less space on the plot. That's generally a good thing. So we got a pretty nice plot here. We could probably improve this plot further using the main xlab and ylab arguments, but those are fairly common to different plotting functions in R and in this R package. So I won't do it, but just wanted to focus on the different options you have with compmeansC, where you can create different types of plots. For point and line plots, you can add confidence intervals using that plot.ci argument, and then as you see here, control the labels on the plot using the IV Labs argument. And the nice thing about using the IV Labs argument is the original levels in the NES party ID 7 variable aren't changed. The variable is undisturbed, and we've only modified the display of the table and of the plot. So our future analysis of NES party ID won't get disturbed. It just kind of fixing an issue right at the level that it comes up, so you don't have unintended consequences. So I hope that helps you use the compmeansC function to create good plots to support your mean comparisons.